All right. This is going to be about the parent functions that go along with our polynomial chapter. We're going to look at two of them that are related to each other. The first will be what we call an even power function. There's some new concepts that we're going to get on these functions that we haven't done before. The basic form is f of x equals x to the n, where n is an even number, positive even number. Throw that in there too. N is positive. Our arrow diagram, nothing groundbreaking here. This raised to the nth power. We are going to introduce some new things on here. In particular, we're going to put a negative infinity as one of our inputs, along with a negative 1, a 0, 1, and a positive infinity. We'll come back and explain those here in just a minute. Our negative 1, when it gets taken to an even power, negative 1 to an even power is going to come out positive. The negatives will cancel each other out. 0 to an even power is 0. 1 to an even power is 1. And so we'd be able to quickly sketch a graph there. This is 1, negative 1, and we'll put this at positive 1. So we have points here that look exactly like the points that we had for the quadratic and for the absolute value function. And certainly the quadratic is an example of an even power function, so its graph looks more or less like the graphs of x to the fourth and x to the sixth. It's just as the powers get bigger on the even power functions, the sides of the graph get steeper and the bottom gets a little bit flatter. Okay, let's talk about those infinities. This is where we're going to capture our idea of the end behavior of the graph. When we talk about the end behavior, we're talking about what is happening as we go out towards the very ends of the x-axis. So in this case, as we approach the left end of the x-axis, our output values are climbing toward positive infinity. They're getting very, very large. And as we go toward the right end of the positive x-axis, then our outputs are also, again, getting very, very large. Okay. So we talk about this in words like as x approaches negative infinity, which is referring to moving out this direction towards farther out the negative x-axis. On this side, we're talking about as x approaches positive infinity. Make that just positive. This direction on the positive x-axis. And when we do either of those things in this case, we can talk about the output, the f of x, approaching positive infinity, which this is an output thing, so it's the output axis. This is talking about outputs getting very, very large up the positive y-axis. Okay. So when we describe that, or when somebody asks us about the end behavior of a function, we summarize it this way and say that for these functions, as x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, f of x approaches positive infinity. The other things we have left to fill in then on the even power function, would be domain and range. Our domain is all real numbers, but the range, because of the even power, is just y greater than or equal to 0. And if we want to reverse this process at some point, we do that by raising to a 1 divided by n power. It's a new thing, and that's a function we'll look at by itself next semester. All right, our other one, we should be able to go a little bit more quickly. This is the odd power function. And our odd power function initially here doesn't look any different except that n is odd and positive. The arrow diagram looks almost identical. Again, the n is odd or positive. We have same standard inputs. -1 now to an odd power is going to come out as a -1. 0 is going to come out as a 0. 1 is going to come out as a 1. So let's plot those points. This is the 1, the -1 here, and a +1 there. So we get points here. I'm going to move that -1 so a little bit easier to see. And a point here, and a point here. This looks like our linear function, but this is, and linear function is kind of like an odd power function. It has a very different shape than the rest of them. Okay. But our shape here is going to come up this way, kind of like a parabola that's been flipped over, flattens out briefly, and then comes up through here and climbs like the other side of the parabola. Okay. This looks probably most like an x to the 3rd power, or x cubed, but the x to the 5th and the x to the 7th look very similar. They're just a little flatter in the middle and a little steeper on the sides. Okay. We can see a different in behavior here. Our in behavior this time says that as x approaches -infinity, so as we go this way out the x-axis towards the out the negative x-axis, our y values, our outputs, are going way down the negative y-axis. So as x approaches -infinity, f of x is approaching -infinity. And on the other side, it looks very much like the even power function did. As x approaches +infinity, f of x approaches +infinity. Again, as I go out the positive x-axis with my inputs, the corresponding outputs are getting higher and higher and climbing farther and farther up the positive y-axis. All right, that is what the even and odd parent functions look like, and you can get those copied into your notes.